Welcome to another episode of Progress, Potential, and Possibilities, discussions with fascinating people designing a better tomorrow for all of us. I'm your host, Ira Pastor.
Welcome, everybody, again to another episode of our show. Today, bringing another really awesome guest. Today, we have the honor of being joined by Dr. Jiangying Zhou, who currently serves as Associate Director at Raytheon BBN, which is a advanced technology research and development organization. It's part of the Raytheon Intelligence and Space Division of Raytheon Technologies, the American Aerospace and Defense Company. And their group has really been at the forefront of innovation for over 70 years now, involved in the early days of email and ARPANET and creating the first metro networks protected by quantum cryptography and all sorts of other cool things they've been involved in. Dr. Zhou, prior to her current role, served as a DARPA program manager in the Defense Sciences Office, where her areas of research at the time included machine learning, artificial intelligence, data analytics, as well as intelligence, surveillance, and reconnaissance exploitation technologies. And prior to DARPA, Dr. Zhou was a senior engineering manager in the Information Sciences Division at Teledyne Scientific and Imaging. And during more than her 10-year tenure there, she was involved in many contract R&D programs with the U.S. government, funding agencies, as well as commercial customers in the area of sensing, sensor exploitation, signal and image processing, and pattern recognition. She also served as director of R&D of Summus, which is a small startup company specializing in contract engineering projects for the U.S. Department of Defense and commercial customers in the area of video and image compression, pattern recognition, and computer vision. She began her career as a scientist at the Panasonic Technology Organization in Princeton, New Jersey. And there she conducted research in areas of document analysis, handwriting recognition, image analysis, and information retrieval. She did her bachelor's science and master's of science, both in computer science at Fudan University, did her doctorate in electrical engineering here at the State University of New York at Stony Brook, and is a member of the Institute of Electrical and Electronic Engineer Society, as well as a member of Pi Upsilon International Honor Society for Computing and Information Disciplines. A lot of really exciting themes to get into today. I'm always excited when we get a chance to talk to her. But Dr. Jiangying Zhou, thank you so much for taking the time to come on the show.
Thank you very much, Ira, and really great to talking to you again. I remember last time I spoke with you, I was still a DARPA PM. Now I have left this role and doing some new and exciting stuff. So I'm really looking forward to the second conversation.
Yeah, me too. And as last time, I would love to start off by handing you the floor for a few minutes, just to tell the audience just a little bit more about you and your background, a little bit about where you grew up, a little bit of what got you interested in both computer sciences and electrical engineering, and a little bit of those very early days that started this whole really fascinating journey off.
Sure, certainly. Yeah. So that was actually a long time ago, tracing back all the way. More than, I think I have been doing AI and machine learning, in this particular research area for more than 30 years, right? So I was actually born in China and started my earlier career in China. So you heard I got my bachelor's and master's degree in China in computer science. Then I decided to pursue a PhD in the United States. And ever since then that I stayed on and became a research scientist. I am a scientist and engineer in my heart. So whatever I do, this is I'm passionate about. And you asked me, how did I get into this AI ML field? This actually is an interesting story. So the short version is accidentally. The long version was, I actually decided to go to university at a very young age, about 16. And during that time, China just emerged from the 10 years of Cultural Revolution chaos. And everything just reopened, including universities, because the universities actually in China at that time had been closed to the public for 10 years. So everything reopened. Everybody, I was about to graduate from high school and had an opportunity to study in the university. And for 16-year-old girl, I actually had no idea what the university is about. What are those different disciplines about? I was always on top of my class. So during those times, if you are good in science and technologies, you go to math or physics. So had been my own choice, I probably will become a mathematician or physicist. But so my parents, obviously, since I was too young, so they were trying to help me to choose a discipline, and they decided, oh, there's the computer science. They didn't actually know what was about, and it is a brand new discipline. And because prior to that, there was no computer science department. So they looked at this, it was very, very new. Why don't you just go there? So that's how actually I ended up studying computer science. And, looking back many, many years later, I really wanted to thank my parents for choosing that particular discipline for me. This is really, really a wonderful area of research. Not only that you could be very, very geeky about it, that one of the stereotypical computer scientists, those geeky coders, and get fascinated with Star Trek. I'm actually a Star Trek fan, for example. I watched all the Star Trek, multiple generations. But at the same time, actually, you could also be, get involved into really, really fascinating, deep questions about intelligence, about what is knowable, what is unknowable, what do you mean by computation? And so that's why you have this pretty, wide spectrum of getting to nitty-gritty details of writing code, at the same time asking really deep questions. And this is also, an area right now it is experiencing a renaissance, right? Everybody's really getting excited and about the latest, greatest technologies in this area. So I actually, as I told, for example, a lot of people in our company, it is a great time actually to be a computer scientist right now. So that's a long journey, and I probably experienced all the up and downs and all the different, different ideas about AI and machine learning, and I got to today. And I'm even more excited, looking forward to the future about how this field is going to unfold and going forward.
Well, it definitely is unfolding at an amazing pace all around us. And, I have to say, as I was joking before the show when you and I were chatting, I come from a life sciences background, and, although a lot of what I listen to you, I'm just amazed by it all, a lot of it going over my head. But one of the things I always appreciated, the last time we chatted, and when I was looking at a lot of your publications in the peer-reviewed literature, you had this very sort of interesting sort of convergence in the sense that you were bringing together, your expertise in computer sciences and electrical engineering, many times with biologic concepts, which I found fascinating. When you're at Panasonic, you published on genetic approaches to the analysis of complex text. At Teledyne, you were looking at sort of the complexity of the mammalian visual system in the way you were doing our computer vision. Talk about this theme of sort of the convergence of what you do sort of on that AI ML front with biologic concepts, as you were saying, new ways to sort of rethink and reimagine how intelligence works.
Certainly, yeah. And I think last time I talked to you about the convergence, I also mentioned this, wonderful alternative potential intelligence that involves the squid, right? Yep. And I think as this area actually progresses, there's also people are starting to hypothesize this yet another form of intelligence. So, I will talk a little bit about that. So, part of the reason I originally, is very interested in this convergence between biology and AI and machine learning. So, for one, is that in fact, actually, so intelligence, the only form of intelligence that we know to exist in nature, in the biological world, in the form of people and in the form of other living creatures. So that's part of the motivation. People are looking to the biology to look for inspirations. And even with, beyond the intelligence, even if you are just talking about computing, because these two are related, right? Intelligence about the processing the information. So it is how do you compute it? And so this is another area that people are looking to the biology, because the biological world actually offers fascinating examples of very efficient and very effective computation as well. And just to give an example, I think everybody probably in the computer science domains probably have heard about the Turing machines. Mm-hmm. And there's also this talking about Turing machine tests. So a lot of the modern computing technologies are building on the Turing machine models and the von Neumann principles. But there's actually a parallel between the Turing machine model that is in computer science and the DNA structures the biological use. Because in Turing machine models, what you have is you have a long tape of binary 1 and 0s, and you have a machine reader that reads those numbers, and each time you read a bit of information, you change the outcome, and that's how you actually get to realize computation. And in fact, that there's a proof, for example, in the computer science domain, saying that this form of architecture actually can implement all the possible computation that is computable. Now, in the biology, the same thing is that the information is encoded in this long chain of DNAs, and you have a protein mechanism to read the codes that's encoded in the DNAs, and that triggers chemical biological processes, and it's similar to how the reading and the interpretation of the binary 1s and 0s in the Turing tape triggers a change of the outcome of your algorithms. So if you consider people as an algorithm, then the reading of those DNA sequences actually causes the state of the algorithm to change. So you see this striking parallels between the biology and computer science, and in some domains, the biology actually has figured out a much more efficient way of achieving the computation. So one example, I do not remember what I mentioned to you the last time I speak to you, is that the protein folding problem. Mm-hmm, mm-hmm. And right, so the proteins need to be folded in specific structures in order for them to function. In biology, proteins just fold naturally into the right shapes, three-dimensional shapes, yep, very quickly in a matter of milliseconds. And in the computer science, people are trying to also develop algorithms, trying to actually predict, given the sequence of DNA chains, what are the 3D shapes they will be folded to? It turns out that computation is going to take very, very long time if you are trying to implement algorithms. So biology is using more than simply a brute force search to figure out what is the right way to fold a chain of DNA structures, so that it can actually fold it very, very quickly. In a matter of a few milliseconds. In the computer, it will take years. So by comparison, there's something we are missing in our current computer science's approach to that particular form of computation that exists efficiently in biology. So that was actually one of the programs that I started at DARPA, the computer that what's the name of the program?
Nature is the
Nature
computer.
is the computer. Yeah, Nature is the computer. Yeah, I'm trying to remember. So that's basically trying to take lift the page from nature's way of achieving computation. So biology is one example. There's other forms of nature processes. They are effectively also achieving computation. So that you now see why I am so interested in the connections between computer science and biology. And so this is just about talking about computation. When you're talking about intelligence, everybody is always, people, the form of intelligence that existed in humans. I mean, that's right now the gold standard. So that's where all the computer science and AI machine learning aspire to achieve, right? So that's the other another, you clearly see the connection between how the brain. So one of the things I always ask people, or I mean, basically be fascinated about it, is that I ask people that we people only eat 3 meals a day, 2,000 calories, but we do a lot more things, a lot more intelligent things than a computer that can do. So you can give an example that Google's, the deep mind, it takes a huge amount of energy to learn to play games. And so there's still a form of efficiency that about intelligence that in biology we are still yet to achieve. And so that's what I think we still have a long way to go for AI and machine learning domains to figure that out. Because there are already people complaining about some of those latest, greatest technology achievements eating up, causing global warming
right
by running out all the computing resources, right? So there definitely is still a gap between the way that the biological systems achieve intelligence and computation, and then the silicon version is doing it. So that's the fascinating questions for any researchers in this area to investigate.
Yeah, and mentioning nature as a computer, and when you and I last chatted, I think you were sort of just starting out in the Defense Science Office program manager role, and you sort of took us through some of these programs. One of them, obviously, as you were just saying, this biologically inspired concepts, and then some of the other things which were paired with this, which were equally, I still just think about them today, and I'm amazed. You talked to us about an AI that becomes aware of its competence, and it's doing things right or wrong. Trust about ultimately how we build the systems that I can trust the AI that it's diagnosing X, Y, and Z the right way, or there's a lot of other great examples. Talk a little bit, obviously, to the extent that, obviously nothing confidential or anything, but, you came through your DARPA experience, and, DARPA only allows you a certain amount of time, and then you got to pass the projects on to somebody else, and now you're doing the next greatest thing in your career. Talk about your time at DARPA, the experience that you had there, obviously, in this really high risk, high reward environment, which we're kind of free to explore some of these bleeding edge concepts. And then just as a side note to that, as we were chatting before the show, I've had the opportunity to interview not just folks from DARPA, but people from some of these other ARPA groups that are being set up by the U.S. government in recent years. What do you think about sort of the expansion of the DARPA model? Is DARPA kind of a unique thing, or how easy do you think it's going to be, whether it's in energy or healthcare or a variety of other these disciplines, to really get the secret sauce that DARPA has going for it?
So there's actually quite a few number of questions packed in there.
Take a couple hours.
Yeah, so maybe I'll start from the very beginning. So basically, first, everybody. So DARPA's model is everybody only stay there for a couple of years and then they leave, right? So I think probably I share the sentiment with many DARPA PMs. By the time you're leaving, you feel like your job is not done, right? You have a lot more things that you want to do, and so the two things, you're hoping that people succeeding me, the new PMs coming in, that they will tackle some of those hard problems that I recognize that should be done. The other is that's part of the reason I joined BBN. So as you mentioned, that BBN is one of those contract R&D organizations that actually is best known actually for its work with DARPA and has very illustrative histories in doing high-end frontier research. So part of my motivation joining BBN actually is that I'm hoping is that now I may be able to push the for organizations like DARPA or ARPA-H in other places to tackle some of the problems that I recognize that should be done, and maybe from a different. Now I'm on the outside pushing. That's slightly different from you're working from inside. I mean, every PM's time at DARPA is very limited. That actually is part of the attraction that I feel working in DARPA. Because one of the things I actually always enjoy as DARPA PM is this can-do mentality. However, the outside world is running wild and having really difficult hard problems, the PMs actually always coming in and have this attitude that I have an idea, I might be able to fix something. And that's, I think, part of that attraction is coming from the fact that everybody is only allowed to stay a couple of years, 4 or 5 years max, and they joined the agency with a mission in mind, and they know that their time is limited, and so they're always in a rush, trying to get things done. So you always, every time I walk into the office, I just see when you're chatting with the other PMs, you always feel like, whoa, they have this great ideas. That sounds wonderful. And it's just that kind of spirit is contagious, and also makes you feel, that you want to do something the same. Is trying to not see the world as just as a problem, but as a challenge. That however, that everybody can only do a little bit of trying to make it better, but this is a time and space that you have the opportunity to do something about it. So I always cherish that feelings, and always trying to actually tell myself that wherever the job you end up with, I think you want to actually have the same kind of spirit that take the challenges as opportunities. And so that's how I see DARPA, and I know that a lot of different organizations recognize the success of DARPA. I wanted to imitate, and first of all, I want to say there's only one DARPA. There's something unique about DARPA. There's many different reasons why DARPA is a successful organization, and many past attempts to copy or imitating its way of doing things, it's not completely successful. But so I do not necessarily want to get into those details. I have my views why. And I also feel it's great that the organizations, they're trying to imitating some aspects of DARPA's way of doing research. And I think each domain is different. So there's not necessarily you have to exactly replicate DARPA's approach, because DARPA is set up to address some DoD challenges.
Sure.
And for example, the ARPA-H and they actually are gearing up for addressing equally great challenge, but it's different. It's more tailored to the civilian, needs and applications. So so I think it's a different. It's a different problem space that each of those organizations is trying to operate, and probably they should actually find their own ways of success. So that's how I see it actually. It's wonderful actually to see people trying to do something similar. So
gotcha. Yeah, it's interesting because when I look at Raytheon BBN, in some ways it looks like you have a little almost Raytheon DARPA there, in the sense. I think of Raytheon and I think of space stuff and space shuttles and all sorts of other defense and space equipment. But I go to the Raytheon BBN site, and you got synthetic biology and quantum computing and all sorts of other neat things. I read this. I was unaware of this, but I was read that in the Cambridge area, it is referred to as the third university next to
University,
Harvard and
exactly,
MIT.
yeah.
Obviously, to the extent that you can talk about what you're up to nowadays in general, because clearly you come from DARPA, you did a bunch of really cool projects. Can you say a couple things about what you're up to today?
Sure. Yeah, so when you notice that actually you have a very keen eye to notice that BBN is almost like a mini DARPA. I mean, we're not trying to claim this as DARPA, but BBN actually is very unique. It is a wholly owned subsidiary of Raytheon, so we have maintained somewhat independence from the corporate technologies and the business, and that gives us actually the freedom to investigate and do research and to chase new directions in terms of the foundational research. So this actually is a great thing because a lot of times, so BBN is not exactly a corporate research center. That's what I'm trying to say. Corporate research centers have to speak to the corporate's core business. We also do, but we also maintain a bit of a distance, right? So that allow us to venture into areas. Initially, you may not see why that the Raytheon as a company should care about, but a lot of times technologies show up several 5-10 years later that the relevance will show up. So you notice that the BBN has a research focus that is synthetic biology. And Raytheon is a company that does not really have a strong synthetic biology domains. However, so some if we are it's tightly connected with the corporate, then there will be a bit of a justification that we have to do, right? But synthetic biology is a growing a new area of research, and that potentially can offer a lot of really interesting technologies. And both in terms of, for example, combating the current, the disease and pandemic, and also actually also have a connection to computing. So remember I mentioned to you that a lot of the biology process could be actually considered as a form of computing or memory. So people have been, for example, using the DNA as a way of storing binary ones and zeros as stored data, right? So that's why that's part of the attraction, that part of motivation for me to join BBN. Now I'm coming from AI and ML background, so part of what I would like to do, as I mentioned at the very beginning, that when I left the DARPA as a PM, I felt like my work has not been completely finished. I see a lot of new challenges, and that in the AI ML that I would like to actually have the opportunity to tackle. And this actually, even some of those challenges I see, related to human-machine teamings and related to what do you mean by intelligence, becoming even more urgent and concrete as you see the success of AI and machine learning lately, with the success of the language models, for example. So I feel that's actually is one domain that I would like to do, is to leverage the research capabilities and backgrounds and bring trust within BBN, and to help actually to promote and shape some of those research efforts. And also, so one of the benefits also for BBN to be part of the Raytheon is then it's unlike a completely independent research focused organization like universities. We also have opportunity to connect our research with some of the real world challenges, right? So that Raytheon is a defense contractor. So the big Raytheon is dealing with a lot of really, really large scale, big national security problems. And nowadays, all those national security challenges probably all involve AI and machine learning technologies as part of the components. So being part of a bigger organization will give us, meaning BBN, an opportunity to connect some of those advanced research that we do with the real world problems. So that's another advantage when I choose BBN to be my next stop.
Yeah, I mean, it's just, listening to you, and then also, yeah, as I said, looking at this portfolio, that, and it says, sort of that the wet lab investigations, and sort of the AI methods, bring them together for really a wide range of possibilities. I'm excited for you, especially based on where you come from. So it seems like it's sort of DARPA 2.0 for you, and continuing a lot of these themes. So that's really exciting.
Yeah, I also would like to kind of add to it. Actually,
Sure.
it's a two-way process. So not only that I see there's opportunities for us to connect into the advanced research that is being done in BBN, to the larger Raytheon challenges. Also, actually, is help us, meaning researchers. Well, I see myself as a researcher, to appreciate where are the real challenges are. Sometimes, if you are focusing on the technology, or engineers are focusing on chasing the technical advancement, but fail to appreciate if the real world has a different set of problems.
Right.
Right, and so with that connection, that you get to see some of the real operations on the ground. You really want to develop a technology that's useful to support, for example, our mission partners.
Excellent. While we're on the topic, and you talked about obviously the excitement that's been going on in recent months, and specifically the sort of the public facing excitement on this Chat GPT thing, which I've tried to log into. I've never gotten in, so I can't. I do know that there's been a couple students at one of my kids' schools that tried to hand in an essay already from the thing and got caught. Take a little time to. I mean, I have to describe what it is, but I mean, as an expert, and when I take my hat off to you, I mean, as a real expert in AI, machine learning, on the cutting edge. I mean, what is this all about? How excited should I be as a pharmaceutical industry guy? How excited should my kids be? What's going on here? And bring us down to earth, if you would.
Yeah, so I actually have multiple feelings towards the latest news frenzies about ChatGPT and language models. So I am simultaneously excited, a little bit disappointed, and somewhat concerned. So I'm going to try to walk you through. So the excitement part, obviously, this is actually does represent a huge progress in the AI machine learning domain, right? So language is the hallmark of human intelligence, right? We interchange, we talk via language. Whatever we do, the knowledge we learn, we eventually commit to language in the form of books, right? So the latest version of the ChatGPT, and there's some other similar language models, showed that the field has made a huge progress being able to process language, to understand the essence of what you're asking about, and to be able to meaningfully provide reasonable answers that are actually it sounds like it is actually a good answer in many cases to the questions. So this ability to understand what the language is trying to convey, and to be able to respond represents actually is a major progress in AI ML field, and also opens the door for a lot of possibilities. So one particular example I will give is that so people have been talking about human machine teaming forever, for many years, right? But in the past, when you're talking about human machine teaming, you usually means is that the AI developers or researchers are going to design some schemes, and they're going to be trying to force upon people, meaning that you have this UIs and this specific formats that you have to follow in order to interact with the computer software. And oftentimes that's not very natural. So people don't feel, people's way of expressing themselves are generally via language. So with this language understanding capabilities, now we actually, I feel like you can meaningfully talk about human-machine teamings, because you allow humans to express their ideas, their desires, their understandings of the world via the communication means that they are naturally good at is language. And now the computers have the ability to process and properly understand, and they can internally do whatever they want and to respond properly. So that basically opens a lot of opportunities, and I see. And the fact that there's such a excitement in the public space, and everybody's talking about it. Other people are trying it out and fascinated about it. Even the taxi drivers, if you take a ride, they're talking about ChatGPTs, right? So all this excitement to me also is a good thing, because that raises the awareness from the public about a piece of technology. So a lot of times, how do you get a layperson to be interested in technologies? A lot of times they just go way, over their head. But in this particular case, people do relate to it. They understand what it's trying to do. So this kind of public awareness also means, this I'm speaking now as a researcher in this domain, means is that there are potentially more interest in investment, in additional research and additional business opportunities. So that's good for the field. So that's the exciting part. The part I'm a little bit disappointed is that so I used to so the ChatGPT is a product of OpenAI, right. And used to be there actually a bunch of these kind of organizations, OpenAI, DeepMind, there's several of those companies. I used to admire them because they publish papers, and those are really great research papers. They come up, the best and the greatest ideas in AI and machine learning. And the OpenAI is now becoming part of a business, so they are starting to becoming a little more opaque. I think they are less able to publish. And so that was the disappointing part, because as a scientist, you care about the scientific progress, and I think the OpenAI has a lot of great researchers there. They're probably doing a lot of great work, and probably they are a little more limited now in their ability to share some of their ideas with the public. The concerning part, actually, there's two parts of the concerning, and part of that I see as a challenge, an opportunity for us actually doing the research in this area. So the concerning part is that, so one is that, as I mentioned at the very beginning, that language is the hallmark of human intelligence. It's also the way that we, people, interact and understanding each other. And now you have actually a piece of technology that can very efficiently and mass produce large quantity of things. And some of those are correct, some of those are incorrect. Regardless of whether they're correct or incorrect, I sometimes use the term polluting the public discourse. In a sense, is that in the past, when people talk to each other, even you accusing the other side, there's misinformation or misinterpretations, at least that represents somebody's point of view. And that is a way for us to interchange and understand each other and communicate. And that's important for for our democratic discourse. And if you have a piece of technology that can chunk out a lot of stuff, you don't know whether they're associated with any motivations and purposes. And I don't know what is the implication of that for the society. And, if you have a lot of conversations that are not tied to anybody's desires, point of views, And what does it mean when you have, right? So that's what I see is potentially something that we have to deal with. I mean, technologies are here, so that we both as a society and as a technology developers, we will have to find a way to deal with the consequences of that. Right. So it's not the fault of the technologies. It's just it changed the how the information actually exists in the public space. In the past, it's mostly whether it's noise, whether it's the correct information, whether different points of views that all expresses about human desires, human emotions, and human understandings. And now I don't know for sure that potentially a big portion of that is not associated. Right. So that's one of the concerns that I have. And the other is obviously is this concentration of technologies, right? So I'm pretty sure OpenMind is doing the right, they want to do the right thing. That every time I think they are very, very responsive when people find out that it doesn't work well, I query the system, they quickly actually trying to fix that. But still, you are seeing a concentration of technologies in a small group of people or organization, and they are not necessarily very. The transparency is potentially an issue, right? And in the past, for example, when you Google materials, that it will show you that where it's coming from, and one of the authority of the information is coming from Wikipedia, and the whole Wikipedia text is for you to look and see. And now you have a piece of technology that will tell you authoritatively, or whatever the question you ask for, and so that also has implications.
Sure.
That I think there will be a long-term consequences for that. That I think the public and also the AI community is just beginning to pondering over, and potentially probably require additional research and development so that we utilize the technologies correctly. So that actually ties to another topic of interest. When I left the DARPA, I was very interested in, and I think the topic becomes very urgent, is the responsible AI, right? So how do we make responsible use of the AI technologies? And the technologies, the progress of the technology is such that this is actually an urgent, becoming more concrete and urgent for us, for the communities, and actually also for the public to deal with it. So I see both, more challenges. Sometimes I say the success begets challenges.
Right.
Challenges also means opportunities. So in some sense that it is also good for it opens actually. So those are open questions for the AI ML research community to ask, and to try to see whether we can find better ways to deal with it.
Right. Yeah, no, it's I appreciate distilling it down like that, and pointing out the different issues that we all have to think about, especially the next generation and these kids upstairs here that think it's the greatest thing.
Yeah, that actually, that's another actually potential challenge for especially for parents. You have young kids, right? So what is the future? Actually, they will have wonderful tools, but those tools also have consequences, right? So if you can simply ask the AI to write an essay for you, what is the meaning of learning?
Right.
And how do we still make sure that kids are still able to learn properly? I mean, so that's what I'm saying. There's a lot of potential implications about the success of this technology that we probably it's not. This is it is more actually for everybody, because this involves all of us to ask a question and to deal with it.
So well, as again, the last time we chatted, as I said, it was early on in your DARPA journey, but I asked you a question of what things you were looking at, after the fact, what was interesting you, and this is where the octopus came up, and you were talking about alternative intelligence architectures, and explain here's this animal that has a tiny brain, but it has all these other little brains, and ultimately how it feels around and experiences and thinks is just totally alien. And it's interesting. I brought you up on other shows because it's interesting how many people are interested in octopus intelligence, from Christoph Koch at the Allen Institute, Mike Levin up at Tufts. I mean, it's really the octopus is it's on a lot of people's minds, and you were the first person to bring it up. Any octopus stuff going on, or any alternative intelligence projects, a la creepy, crawly, slimy critters that you can talk about, or is that
Yeah. So
side
first
projects?
of all, I want to disclaimer: we're not BBN has no creepy stuff.
No octopuses there. That's fine.
Somewhere growing on aliens. And I remember last time I mentioned to you is that somebody pointed out, if you want to look for potential alien intelligence, and the octopus is the closest on Earth, you might want to use as a reference.
Right.
But interestingly, lately, people are hypothesized, and so the jury is still out there. I'm not completely convinced, but people are hypothesized is that the language model, the ChatGPT, obviously that's still, it's not truly an intelligence, but it is actually representing potentially another form of intelligence. So let me work back a little bit. Is that so both the octopus, even feels alien to us, and the human intelligence, both these forms of intelligence are embodied intelligence, meaning that intelligence has a physical force,
right? And
it can sense, it can interact, and can react. And so there are discussions and debates in the AI ML community is whether it is possible to have a disembodied intelligence, an oracle, for example, and represented by the future directions of the language models. And so the one camp of the researchers basically arguing is that as we advance further this language-based models, that we might actually see intelligence and even super intelligence emerge. Now the argument from a different camp, also from the IML community, basically says is that true intelligence is about understanding of the real world, and requires a physical body to interact. And without that, all you can learn essentially book knowledge. They are not necessarily intelligence. So the question is still actually, so that actually becomes an interesting question, right? So whether there's truly the humanity now can create a different form of intelligence that does not require a physical system, because so far the only non-intelligence known to exist, non-example of intelligence that exists in the natural world is embodied intelligence that always requires a physical body. So even the octopus has body,
right?
That reacts to the world, right? And you touch and feel, you impact. And so the question is that language model that doesn't have any senses, doesn't have any other, that cannot really interact with the physical world, meaning that some of this knowledge, if you push let's say a ball, that it's going to move, and there's a gravity will play in effect, and if the snow on the ground, the slippery, the friction comes into play. I mean, these kind of knowledge only comes into via interactions and sensing and interaction with the physical world. So the question is, I mean, a lot of this knowledge is already documented. So the question is, by digesting and ingesting all those books about, about those experiences,
right.
that will be sufficient for the AI to eventually learn to becoming superly intelligent without requiring a body. And so that's what I'm saying, is that there's potentially a debate about whether there's another form of intelligence that we potentially can create. So an oracle.
It's funny because as I'm listening to you, you mentioned this. One of the shows I did a little while ago was with the folks down at NOAA from the hurricane research. They have a supercomputer down there that does all sorts of modeling of storms, and then they have another thing. They have this hurricane machine where it's like a big swimming pool in a box or whatever, and it makes little storms. And one of the questions I pose is, can the supercomputer ultimately learn what it means to be windy and wet? and is this a bridge to something? But we didn't go anywhere with that. But I'm glad you brought it up. It's a fascinating concept.
Yeah,
glad you're thinking about it.
Well, it has some analogous to it, right? So you may be mathematically understanding and be able to accurately model the storms. Well, does that mean that you actually understand the what does it mean to have a hurricane, for example? Now somebody might say, "Oh, I can," maybe a lot of people are writing about it, so I can just read the books and analyzing the books, and I will have a feeling about it.
Yep.
At least on the surface, that I can tell you how it might feel.
Yeah.
But that's actually also speaks to another aspect. So that's why I said the jury is still out there. I'm not completely convinced, because in the human intelligence, and we have so many. We have how many people on Earth? Right? Everybody experiences the world differently. Everybody interprets and feel the world differently. So you have multiple variations of intelligence.
Yeah.
And those are from different experiences, different perspectives. And you understand the world actually differently, slightly differently. At the fundamental level, obviously, the physics is the same, but still, what does it mean is still different. So if you have a oracle-like AI that does not require you to feel and touch and truly experience, does that mean there's only one version of of that? There's no variation, or no meaningful variation. So I actually do not know. I don't think that actually. Are we envision, for example, that disembodying intelligence is just this super godlike things, right? Anyway, so.
No, it's
speculation.
lot to think about, but I'm glad I'm glad there's people like you that think about it, because I'll follow your lead.
So part of that BBN actually, one of the research focus in BBN is natural language processing. So so you will see that's why that's actually the other motivation, because I see the convergence between language and AI and ML. And I was actually really surprised is how fast that convergence had happened. I originally thought I thought that there's a deep connection between language and AI ML. So an organization that has done a lot of research in the natural language domain, will be the place for me to to try out some of those combinations ideas. But the field exploded right now. So sometimes when you're talking about technology's inflection point, sudden explosion, that's one of the moments. Actually, this is one of the rare moments, I guess, in those long histories of technologies, that you have something changed, and that completely changed the nature of our way of life, basically.
Yeah.
And we are kind of, I think, at that moment. So there's also a fortunate to experience that.
Absolutely. JC, I know we're getting to the top of the hour now. Just while I have you, any as we're entering 2023 now, anything else coming up that we should know about in terms of conferences you're going to be presenting at, places that we can listen to you, meet you potentially? Anything else hot on the calendar that you can mention or you want to mention? Please take the floor on the way out.
Yeah, so probably conference. So actually, there's one thing I have been contemplating that I would like to do is actually potentially organizing a research conference and engage for BBN and the company, and maybe even for the larger Raytheon corporations to engage with the public.
Okay.
And I saw the conferences like that, and are very beneficial for both the researchers and the from the research community, as well as the researchers that are within the corporations, because this is a time that there's a lot of synergistic relationships between the different AI challenges, applications, and the different domains. And I think organizing not purely a technical conference that you typically see, but a conference that also that corporate researchers can talk about some of those true, really real world challenge. Some of the real world challenges are extremely complex and at very, very large scales. And to share that with the public and then engage with the public to stimulate the public thinkings about how to address those challenges probably will be actually very beneficial. So that's something that I actually would like to do this year. So exactly when and how, I don't know, but it's something that in the back of my mind.
I'll come to it. No, it sounds,
yeah, if actually it does happen, I'll let you know. It takes a lot of effort to
I believe it. I believe it. But no, it's clearly that would make for an awesome synergy. Again, at the point we're at now with sort of the public facing nature of all this. But no, it's again an awesome portfolio you have there, and just as last time, I really wish you the best with all this, because it's so amazing to see you. I mean, obviously you're passionate about it, but moving forward, these bleeding edge themes, I'm a big fan, and I'm rooting you on. Again, for everybody that is going to be listening to this particular episode of our podcast across the various networks or watching on our YouTube channel, again, you've been listening to Dr. Jiangying Zhou, Associate Director, Raytheon BBN. JC, I want to thank you for taking the time out of your schedule to come talk and educate us for a little while on all these really interesting themes. Obviously, thank you for doing it, and then obviously working on these important topics to keep us all secure in the United States. And as we say on our show here, thanks for helping to create and usher in a better tomorrow via what you do. It's really a great story, and I will continue to root you on and from the sidelines as you keep pioneering these different areas.
Thank you very much for giving me this opportunity. As I mentioned, AI ML is my passion. Anytime, I will be very, very happy to talk about both the technology in the public domains, as well as to the degree I can, the BBN Raytheon's work. So very, very excited. Really looking forward to the future.
Excellent. All righty. Be well then. We'll see you soon. We'll do a follow-up soon.